Welcome to this class. This session, we are going to state the product rule for differentiation, and also prove it. So the statement, so if u and v are differentiable functions of x, then their product uv is also differentiable and dx of uv is given by u dv dx plus v du dx. So this is the product rule. So some people write it as d dx of u v equals to u and then v prime plus v u prime, or some write d dx of u v equals to u prime v plus v prime u. All these are the same things. Now, let's see how to prove this statement. So let's call this 1. So proof of the product rule. So say we know that let the product uv be f, i.e. these two functions u of x and v of x are equivalent to a function f. Their product is a function f. Then we know from definition that f prime of x is given by limit as h approaches 0 of f of x plus h minus f of x divided by h, provided that this limit exists. That's just from definition. So now the thing would be now, how do we define f of x plus h, f of x, and then we put into the definition. So if f of x is given by u of x and v of x, this is already given. And then if you say f of x plus h, then you write u x plus h and then v x plus h. That's what you have. So which means that the derivative f prime of x will be limit as h approaches 0 of u x plus h v x plus h minus u of x v of x divided by h. This is just replacing the values into the definition of the limit. That's the first step. Now we want to play with this expression. So what I want to do, I want to throw a term here, but I want to be very smart in such a way that the term I'm throwing there will not change the meaning of the expression, but it will help me to do some simplification in this part. So I want us to add and subtract u x plus h and then times b of x. So this is what I mean. And next step, I write f prime of x equals to limit as h approaches 0. Now I have u of x plus h, b of x plus h. I subtract u of x plus h times b of x, and then I add u of x plus h times v of x minus u of x, v of x, then divided by h. There is no change I've done to the expression. The only thing that I've tried to rewrite this middle term in a nice way. It's like I'm adding 0 to the expression without changing the value of the expression. So by doing that, now I'm changing my expression from having 2 terms only to having 1, 2, 3, 4 terms. So the next step, I'll have f prime of x equals to limit as h approaches 0. Now this, I take them as 1, and then these other 2, I take them as 1. So here, when you check clearly, this product and this product, u of x plus h is common. So I factor it out, u of x plus h into v of x plus h minus v of x divided by h plus, here now, this product, v of x is common. So I write v of x into u of x plus h minus u of x. And then I divide this one also by h. There's no miracle I'm performing. It's still the same original expression I had. Now, loss of limit allows me to supply limit on these 2 terms. So f prime of x equals to limit as h approaches 0, u of x plus h, and then into v of x plus h, and then minus v of x divided by h plus limit as h approaches 0 of v of x into u of x plus h minus u of x divided by h. I'm just using the loss of limit. If I have sum of 2 functions, then limit is the same as limit of each of the 2 functions. So that's why I'm supplying limit to this term and this term here. Now, also, if I have a product of 2 functions, then I can also get the product of the respective limits of those functions. So the next step will be limit as h approaches 0 of u x plus h times limit as h approaches 0 of this part, v of x plus h minus v of x divided by h plus, now this v of x, this product, v of x doesn't, the limit depends only on x, so I can factor it out. So v of x limit h approaching 0, u of x plus h minus u of x divided by h. And we need to be celebrating because if you check this part and this part are actually the definitions of derivatives. The only difference is that here is v and here is u. But remember, limit as h approaches 0, f of x plus h minus f of x over h is usually the f prime of x. So this expression here is the same as this one. The only difference is that now we have v here and we have u here, but the same thing. So it tells us that we'll have f prime of x equals to limit as h approaches 0 of this u x plus h. This one is just the derivative of the v function. So this is the same as times v prime of x or dv dx. Similarly, the other part will have v of x will have plus v of x times, this is just u prime of x. And you see this limit here will be the same as u x plus 0 times v prime of x plus v of x times u prime of x. So this is f prime of x. And x plus 0 is just x. So this will be u of x times v prime of x plus v of x and then u prime of x. So this is the final answer. So therefore, hence d dx of uv is the same as u dv dx plus v du dx. And that is the end of proof. So different formats of this. So this is the end of proof. Different formats of this product rule. You can say d dx uv is u v prime plus v u prime. Or you can say d dx of uv is u prime v plus v prime u, the same thing. Or when u equals to f of x and v equals to g of x, then d dx of uv the same as d dx of f of x times g of x, which is the same as f of x times dg dx plus g of x df dx. etc. You can put it in different forms, provided you have the same meaning. So that's how we prove the product rule. Next session, we'll do some examples on application of product rule.